Okay, in a previous video we talked about how mid-segments, when you connect up the midpoints rather, of a triangle, have some interesting properties and interesting characteristics that you can infer from that. In the previous video, in part 1, we talked about how if you connect up the midpoints, like DE is the midpoint of BC, point D is the midpoint of line segment BC, and that point E is the midpoint of line segment AC. If I connected those two midpoints, if I know what this length is, let's say it was like, 6, I can actually infer that the side that's not the midpoint, the side that contains the midpoint not connected, is actually twice the length of this particular connected midpoints, right? So AB would be 12 and DE would be 6. So that was just one of the characteristics from a previous video. Now what I'm going to do this time is I'm going to connect actually all the midpoints and show you another property of midpoints and mid-segments. So if I'm going to connect this midpoint to that midpoint, and this midpoint to that midpoint, and let's just go ahead and call this midpoint F, okay? What I have done here is I have created 1, 2, 3, 4 congruent triangles. Let me say that again. If I connect all the midpoints let me just write this all out. Midpoints in a triangle I will create 4 congruent smaller triangles. Okay, so I've created basically triangle BDF, which would be congruent. Let me just go ahead and start writing this out. So triangle BDF would be congruent to triangle DEF, which is also congruent. I'm going to run out of space here, I think. AEF triangle, which is also congruent to triangle CDE. Okay, that's how you would write it out mathematically. Now, if I happen to know one of the sides, for example, of this particular triangle, like I know this side here is C, the corresponding sides are also, and I know, for example, that this side was 12, remember we said that from the previous video, then I can assume that this side is 6 and this side is 6, because I know that's the midpoint. So if that were 12, each one of those would be 6, and I know that this, for example, is twice as large as that one. Okay, so now look what I've done. I've actually started to find all the lengths of the sides of this triangle. So this point, this line segment DE is 6 for this triangle here. DE is also the 6 for this triangle here. This segment AF is 6 here for this triangle here, and BF, this side, is 6 for this triangle here. So notice I'm really starting to be able to find lots of different characteristics of this triangle just by connecting up the midpoints. Okay? Is there anything else, do you think, that I could find from here? Well, I do know, for example, that this angle and this angle and this angle form a straight line, so it's 180 degrees. Same thing with this angle, this angle, this angle, this angle, this angle, and this angle. Okay? And those all have corresponding sides. Now remember, one of the things I said was that in part 1, that this line segment AB and line segment DE, let me just keep on writing more. So line segment AB is parallel to DE, line segment. And if that's true, then I know that this line segment EF is a transversal, don't I? And if it's a transversal, I know, for example, that this angle and this angle, let me make sure, these would be alternate interior angles, right? So those would be the same. So I know that angle AFE would be congruent to angle DEF. And I know that, right, because they would be alternate interior angles. Now what I'm going to do is I'm going to challenge you to see if you can figure out any other angles that might be equal, okay? Knowing what you know about these mid-segments and midpoints, and what you know about parallel lines and transversals, right? With alternate interior angles and corresponding angles. And I'll leave that to you, and we'll go ahead and create a problem set and see if you can figure that out, okay? Hope this was helpful.